Hi everyone, I'm Kurt Freeman, along with my partners Alex Pig and Thomas Ulke, and for our project we did the Smart Home. So for our talk agenda, we have an abstract, we have project objectives, introduction and background, project principle, block diagram and flowchart, final prototype, project timeline and budget, results, conclusion and next steps, and finally references. So the smart home device has the following goals for saving energy. First, we turn off the lights in unoccupied rooms. Second, we warn homeowners when windows are open while AC is on. And we signal when the room temperature is outside set parameters. So for our project objectives, we wanted to build a system that uses a motion sensor that will turn off lights in a room when it's occupied. We also wanted to develop a temperature detection system that lets the homeowner know when the temperature indoors doesn't meet the standard room temperature of between 68 Fahrenheit and 72 degrees Fahrenheit. And finally, we wanted to design a detection approach that warns the homeowner if any windows are open while the AC or heat is on within the home. So smart homes have been designed to help keep homes energy efficient by helping eliminate wasteful tendencies through monitoring sensors. The idea of smart homes originated 80 years ago, but back then they didn't have the technology to actually communicate through all the sensors to make it efficient as they wanted it to be. And with the limited amounts of fossil fuels, smart homes can help limit usage of these sources and cut down on energy usage that will lead to lower energy bills for the consumer.
Alright, for the smart home device, it was intended to complete its task through use of the input sensors. So the input sensors that we were looking at were the temperature and humidity sensor, which would measure the room temperature, which would help with the AC and heat aspect of the project. And also the other input sensor that we would basically develop was a flame sensor, where it would see if there was sunlight detected. So based on the situation in the room and if like the window is open, let's say the AC is on, but the door or the window is open, that tells the LCD command to tell the person to close those windows to maximize efficiency. And another sensor that we use was a motion sensor, which would help with room lights to see if the room was occupied, then the room would have the light remain on. But if it was empty, then it would turn off the light after no motion was sensed. So the two-tone LED was used to signify this motion in our project. So that's just us making a prototype to show that if it was actually applied into a home setting, that it will work. The 7-tone would signify different temperature from the sensor. So like one color would indicate if it was a warmer room temperature than wanted, and another would show if it's like a lesser one. So we have like a little basically chart to show where it is when we actually apply that 7 LED. And then the LCD screen, which is basically just letting the homeowner know what these sensors are communicating and what they need to do to respond. And then this is our final prototype. As you can see in the far right is our motion sensor with the white dome. And the LED right next to it, right now it's turned on red. That is the two-tone that we applied to our project, where once motion was sensed, it would have the green, it would switch to green LED, and it would have a delay, and we can actually modify that delay with either if we want it to be seconds or minutes. And then our flame sensor is directly above that right here, and it can sense sunlight and or actual flames. So we could actually program a smoke detector almost towards it to see if it is sensing flame, but that's not our main use. Our main use is for the sunlight for the windows. Then as you can see, the LCD up top shows that it is not detecting sunlight because we're actually indoors. So it can actually differentiate between artificial light from lights in the classroom to actual sunlight from the actual sun. And then back here in this far left corner is the actual active buzzer. So once the LCD switches to sunlight detected, this will actually make a noise to let the homeowner know that the window is open and we need to close it because the sun is actually shining through. So, and then this is our block diagram of our entire project. As you can see, the inputs are on the left side with the motion sensor and the flame sensor, and then the outputs are on the right with the two-tone LED, LCD screen, and the active buzzer. So the reason the temperature sensor is not in will actually be explained further, and how we actually came up with a problem in that design phase. So we had to modify our flowchart because of that design change, but essentially it's the same concept as the proposal. As you can see, the program starts, and the microcontroller receives all the information from the sensors. It goes to see and checks if there's any occupation in the room. So if there is, it'll turn on the LED. If there's not, it will turn it off. And then it'll display the current sensor status, so whether the sunlight is detected or will actually output the solution later on. So after that, it'll go through a delay, detect sunlight, activate the buzzer. If there is sunlight, then it'll display the solution that we want the user to do to actually become an energy efficient home.
Alright, so these were the results of our project. We were able to successfully incorporate most of what we set out to include within our device. We were able to incorporate a flame sensor that would be able to audibly and visually make it clear to the user if sunlight has been detected through both the buzzer and the LCD respectively. The motion sensor can be used in real time alongside its other functions and is able to also clearly indicate to the user if there has been motion detected, and would theoretically be used to turn off the lights if no one's in the room, since it would not be necessary and would waste energy. Unfortunately, we were not able to incorporate the temperature and humidity sensor. We ran into multiple technical issues and it took up a lot of time within us working on the project, and with time running short toward the end, we ended up having to scrap it. And this also ended up changing our priorities. So originally we were going to include the 7-color LED to be able to signal both the temperature sensor and potentially if there was sunlight in the room. Since the temperature sensor was no longer included, we decided to instead switch that out for an active buzzer so that we can include another cue with the flame sensor to the user audibly. So this is the project timeline. This looks very similar to the one we had originally. We did have to make a few tweaks where we weren't quite able to fit in what we had originally planned. This usually would potentially be because of other classes or other things that we had to do at the time. Overall, we were able to follow the timeline fairly well, and other small changes had to be made, such as we didn't know at the current time when the final project was going to, or when the demonstration for the final project would be. So we also made changes like that accordingly, and this right here is the timeline we ended up following. Project budget is pretty much going to be the same as last time. We only incorporated 3 potential costs. This was the PIC-KIT 3 debugger programmer, the PIC demo board, and the sensor modules kit, the 37-in-1 that we had to get for this project. So, in conclusion, we were able to successfully create a device that would be able to determine if sunlight is coming into the room and if there is any person in the room, which means we were able to succeed in most of what we set out to do. If we were to take further steps, we would probably try to continue trying to troubleshoot the temperature and humidity sensor and potentially look toward outside help on how to potentially figure that out. And these were the references that we had for our project, which are also the same as last time.